Okay, this demonstration is a video, as this video is a demonstration, I should say, of the product rule of logarithms. And just like the name implies, the product is basically finding two factors of any individual number and then applying it so that you can solve for the logarithm. Okay, so here's the rule already written out for you. Let's take a look at it. This is basically saying that the log of any base, let's just keep it constant, let's say base 10 just for easiness sake, of some number, and notice I already have it written as an xy, but let's just say that number is like 20 or something like that, can be broken out into the log base a of one of the factors plus log base a of the second factor. Okay? Now what does that mean? Let's take a look at this particular problem. We'll call this example 1. Let's say I have log, and let's just use base 10 because that's what our calculators are calibrated to do. I'll say log base 10 of 20. Alright? What we want to do is find two factors of 20 that we can express as a sum. So I'm going to change log base 10 of 20 to log base 10 of 4 times 5. Now I could have chosen 2 times 10. I could have chosen 1 times 20. I can choose any two factors and this will actually work. And I'm going to change that to log, according to my rule, log base 10 of 4 plus log base 10 of 5. Now I can use my calculators at this point and find out what the log base 10 of 4 is and what the log base 10 of 5 is. Now a lot of times what will happen is that you will not have your calculators handy, but your teacher might give you a chart telling you what the logs of like some of these smaller ones are, like log base 10 of 2. I believe is 0.301. Log base 10 of 3 is 0.477. Log base 3 of base 10 of 4 is 0.602. I think it's just twice of what it is of 2, etc., etc., etc. Okay, so you probably will be using a chart to figure out what these are. So the question is, what is log base 10 of 4? Well, log base 10 of 4 is actually 0.602, twice what log base 10 of 2 is. What is log base 10 of 5? And I believe we said it was 0.699, and it is actually 0.699. So again, this rule says that I can add up the individual logs of the individual factors and get the log of the original number. And in this case, it's going to be 1.301. Now let's see if that makes sense in the context of our particular problem, okay? So if we look at our regular problem, it's log base 10 of 20 is equal to something. We don't know what it is. What's the exponent that will make this a true statement? Let's see what we do know. I know that 10 to the first is equal to 10. I know that 10 squared is equal to 100. Now notice that I need to find log 10 of 20. So 20 goes in right about there. So that tells me that my x is somewhere between 1 and 2. And sure enough, when I look and see what my answer is, it is 1.301, which is between 1 and 2. This is probably a good answer. Okay? I hope that helps with the product rule. I'll do a demonstration with the quotient rule in another video.